Good morning and welcome to another episode of Mrs. Ross Does Math. Our lesson for today is for Math 7 and the topic is Lesson 10, Special Ratios of Similar Figures. Let's get this started. Alright, so once again, this is for Math 7. This lesson is Lesson 10 and our focus is Special Ratios for Similar Figures. We're going to go ahead and start out with our essential question, and that is, how can I find the scale factor of ratio perimeters and ratio of areas of the similar figures? In this today, you're going to need to be finding three different things. The first is our scale factor. The second is the ratio perimeter. And the third is the ratio of the area. Those are the three components we're going to be focusing on, so let's get this started. If two figures are similar and their ratio of their sides simplifies to A, B, whole numbers, the ratio of A to B, then the scale factor, our scale factor is the ratio of the two figures when compared together, is going to be written as A colon B, all right? The ratio of the perimeters is A colon B. What this means is that our scale factor is going to be the same as the ratio of the perimeters. So we're going to make a note of that. Same as scale factor. And lastly, the ratio of the areas is going to be A squared to B squared. What that means is that we're going to take the ratio of our perimeter, which is our scale factor, and we are going to square those numbers. Now remember, when we talk about squaring something, it's not A times 2, so that's not going to be 2A. What it is it's going to be A times A to B times B. That's going to be how we'll find the ratio of the areas. Now, a lot of this isn't going to make sense right off the bat, and that is totally okay. What my hope is that by the time I go through this next example, it will make sense. So here we go. In this example, we have two rectangles that are similar. Okay. I have these two rectangles here. In my first figure, figure 1, I have a rectangle of 3 yards to 9 yards. In figure 2, I have a rectangle of 4 yards and 12 yards. What I'm going to do now is I'm going to find their ratio. Now remember, a ratio is a fraction written as a colon in this particular case. So to begin with, I'm going to start out by finding their scale factor. Now I'm going to find their scale factor by setting their corresponding sides to each other. So here, I have 3 to 4. So I'm going to write that as 3 to 4. Next, I'm going to set my bottom sections of these numbers to each other. So that's going to be 9 to 12. Now, when we find our scale factor, it's always written in simplest form. So we're going to check each one of these. My 3 to 4, that's already in simplest form, so I don't need to do anything to it. But my 9 to 12, that's not, so we are going to go ahead and simplify that. Here, 3 can go into 9 3 times, so I'm going to simplify my 9 to 3. And 3 can go into 12 4 times. So we get 3 to 4. Now, because these numbers here are the same, our scale factor is going to be 3 to 4. So 3 colon 4. Okay, so our scale factor is once again the corresponding sides set to each other and put in simplest form. Now, if for any reason these numbers, when you simplify them, do not give you the same scale factor. First, check your simplification. Second, check to make sure that you have the correct corresponding sides with each other. Okay? Now the next thing, we are going to find the ratio of their perimeter. Now in the notes above, I made a statement that the ratio of the perimeters is A:B. Also, it's the same as their scale factor. So if our scale factor is 3 to 4, the ratio of the perimeters is also going to be 3 to 4. So we're going to use the same numbers for the scale factor and the ratio of the perimeter. Next, we are going to find the ratio of their areas. Now, just like before, I said the ratio of their areas is going to be the scale factor squared. So it's going to be A squared to B squared. Now this was A times A to B times B. Here, if our scale factor is 3 to 4, the ratio of our areas is going to be 3 squared to 4 squared. 3 squared, or 3 times 3 is 9. 4 squared, or 4 times 4 is 16. So the ratio of their areas is going to be 9 to 16. If at any point you did not understand a section of this, please pause this video, please rewind, rewatch it. If you're still confused, please send me a comment or leave me a comment, send me a message, and I will do everything I can to help this subject make sense to you. Now, before I get going with your assignment, what I'd like you to do is to please answer this summary down below. It says, when finding ratios of similar figures, I first blank, tell me what the first step is. My perimeter is the same as the blank, tell me what that is. And the ratio of the areas is my blank but squared. Please fill in those 3 blanks. Now, what I'm hoping is that as we go through your assignment, if you are still a little confused on anything, once you are able to see me go through our first problem, things will make a little bit more sense. Here we go. So your assignment is going to be Math 7. This is Lesson 10. Our topic is special ratios for similar figures. As this is 2 pages, please make sure that you write your first and last name on both pages. And today's date is the 16th. All right. So here, I'm going to go ahead and lead you through numbers 1 through 5. Now, the reason I'm going to lead you through numbers 1 through 5 is because it's going to guide you in everything that you need to do for numbers 6 through 11, as well as number 12. Okay, so here we go. So we have 2 rectangles here. Our first rectangle is called bike. B-I-K-E. All right. Our second rectangle is called play. P-L-A-Y. Our first task is to find their scale factor. Now that scale factor is going to be me setting our corresponding parts equals to each other. So here, I'm going to go 2 to 3. And I have 6 to 9. Now my 6 to 9 needs to be simplified. 6/9 can be simplified to 2/3. So our scale factor is 2 to 3. All right. Next, our task is to find the perimeter of each rectangle. So for rectangle B-I-K-E, or rectangle bike, we need to find the perimeter. Now, perimeter is the distance around our figure. So for bike, I'm going to put a little rectangle in front. So rectangle bike is going to be for our perimeter, 2 times the length, our length is 6, plus 2 times the width, in this case 2. So when we talk about perimeter, we're using the equation perimeter is equals to 2 times the length plus the width. So here I'm going to go 6 plus 2, which is 8. 2 times 8 is 16. So the rectangle bike has a perimeter of 16 inches. Next is going to be play. So rectangle play is going to be 2 times my 9, which is the length, plus 3, the width. So I'm going to go 9 plus 3, which is 12. 2 times 12 is 24. So my perimeter for play is going to be 24 inches. Next, we need to find the ratio of the perimeters. Here, the ratio of our perimeter is the same as our scale factor. So we are going to write this as 2 to 3. Now, if we wanted to check this, we could set 16 to 24, which in that case, it does reduce to 2/3. Next, we're going to find the area of each rectangle. Area is length times width. So in this case, for my rectangle bike, my area is going to be 2 times 6, which is going to be 12. Now this is going to be 12 inches squared. Anytime we talk about area, our answer always has the unit of measurement and the squared at the end. Next, we're going to take a look at play. So rectangle play. And again, that's going to be our length times our width, which is going to be 3 times 9. Now 3 times 9 is 27, so I'm going to get 27 inches squared. Now, we are going to find the ratio of the areas. Now, the ratio of our areas is the ratio of the perimeter, which is the scale factor, squared. So I'm going to go 2 squared to 3 squared. Now 2 squared is 4, 3 squared is 9. So my answer is 4/9. Now, for each problem in numbers 6 through 11, you will be responsible for finding the scale factor, the ratio of the perimeters, and the ratio of the areas. So each problem has 3 components that you need to find. In this, please make sure that you are using the same scale factor for the perimeter, and then you're using that same scale factor in the ratio of the areas. If you have any questions at all, please leave me a comment, send me a message. This has been Mrs. Ross Does Math.